This is Physics Chapter 2, Problem 77, and it reads, we've seen that a man's higher initial acceleration means that he can outrun a horse in a very short race. A simple but plausible model for a sprint by a man and a horse uses these assumptions. The man accelerates at 6.0 meters per second squared for 1.8 seconds and then runs at a constant speed. A horse accelerates at 5.0 meters per second squared but continues accelerating for 4.8 seconds and then continues at a constant speed. A man and a horse are competing in a 200-meter race. The man is given a 100-meter head start, so he begins 100 meters from the finish line. How much time does the man take to complete the race? How much time does the horse take? Who wins the race? So we're going to start by computing the values for the man. So we're going to start by using this equation, x equals x initial plus velocity initial multiplied by time plus 1/2 multiplied by acceleration multiplied by time squared. And so our x, we know that x initial is 0, and we know that velocity initial is also 0. And 1/2, we know that our acceleration is 6. They just gave us that. And we know that our time is 1.8 seconds. So we need to square that. And that gives us 9.7 meters. That's how long he ran while accelerating. And then we need to use the equation velocity final equals velocity initial plus acceleration multiplied by time, because now we need to find his velocity that he's running after he's accelerated. So we're going to plug in our values. Our velocity initial is still 0. Our acceleration we had, which was 6 meters per second squared, and our time is still 1.8 seconds. So we multiply those, and we find that his velocity is 10.8 meters per second. Now, we're going to use the equation velocity equals displacement over time, but we're going to rearrange it to find time because that's what we want to solve for, and we get time equals displacement over velocity. And we know he ran 9.7 meters while accelerating, and he's already 100 meters from the finish line, so he only needs to run 90.3 meters, so that'll be our displacement. And then we just found his velocity was 10.8 meters per second, so we get that that time is 8.36 seconds. That's how long it takes him to run the rest. But his total time will be both times added together. So we do 8.36 plus 1.8, and that gives us his total time to run the race is 10.2 seconds. And now we need to do the same thing for the horse. So we once again use the x equals x initial plus velocity initial multiplied by time plus 1/2 multiplied by acceleration multiplied by time squared. We're going to plug in our values for that. For the horse, the initial position is 0. The initial velocity is 0. So it's 1/2. We know that the acceleration is 5 because that was given to us. And we know that the time is 4.8 because that was also given to us. We square that and we get the horse ran 57.6 meters while accelerating. And then we're going to use this equation again, the velocity final equals velocity initial plus acceleration multiplied by time. We're going to plug in our values for that. So our velocity final equals our velocity initial is still 0, our acceleration is 5, and our time is still 4.8. And we get that the horse ran I literally just wrote meters per second. I didn't write the answer. It was 5 times 4.8. Is it 24?
Yeah.
That's fine. Okay. So we multiply the 5 times 4.8, and we get 24 meters per second is the horse's velocity. And so the horse has to run 200 meters, and it already ran 57.6 meters while accelerating, so the remaining distance it needs to go is 142.4 meters. And now we are going to use this equation again, where time is displacement divided by velocity. So we get time equals 142.4 meters divided by 24 meters per second, and we get 5.9 seconds is how long it takes the horse to run the remainder of the race. And so the total time, we need to add both of those values together, so we get 5.9 plus 4.8 equals 10.7 seconds. So in this race, the man will win.